Good morning, good afternoon, good evening, wherever you may be in this part of the world. Welcome to another session of my presentation series. And this time, the presentation topic is electrical power generation utilizing fossil fuel and steam generation to generate electric power. My good name is John Kweku Amotu, and I've been a professional electrical engineer for the past 31 years, and I'm been practicing as an electrical engineer in the United States of America for the past 31 years. Now let's talk about some logistics here. And um, if you like my presentation, don't forget to select the like button in YouTube. Okay. Then don't forget to share. Okay, so below that is my YouTube channel, and this is the name of the YouTube channel, Work and Happiness, talking to the engineer. Right, and for you to be able to subscribe to my YouTube, you need a Gmail account. That is a Google account. Okay, so if you don't have that, then you need to go ahead and create that Gmail account. Then you should be able to subscribe to my YouTube channel. Okay, so this is the subscribe button. Okay, then you can select that button to be able to subscribe. Okay, so this slide basically talks about my YouTube channel. Basically, the name of the YouTube channel is Work and Happiness Talking to Engineers. So basically, you can go there, but for you to be able to subscribe to that YouTube channel, you need a Gmail account. So if you don't have a Gmail account, you need to go ahead and create a Gmail account from Google. Okay, so if you like my presentation, go ahead and select the like button, and don't forget to share that knowledge, because that is very important, especially for young engineers that are about to start their career, and for engineers that are in between, starting their career and mid-career, and also for experienced engineers and consulting engineers. Okay. For consulting engineers, they can be a refresher for them. And also, that helps you, if you create the Gmail account, that helps you to subscribe to my YouTube channel. Okay, so now this slide basically tells you everything that is concerned about electrical power generation utilizing fossil fuel. Okay, so let's go through, right from basically the coal pile, right? So the coal pile basically comes from either, it can be transported either by rail or by barge on those rivers that are in close proximity to the power plant, right? So usually, most often than not, during the feasibility studies, when these power plants are built, right, feasibility studies is performed to determine what means that it can be achieved for the means of power generation, the energy that is required for the power generation can be transported to this power plant. Okay, so as you can see, coal can be transported by rail, right? And also it can be transported by barge, and also it can be transported by trucks. So you can see this 18-wheeler trucks transporting this pile of coal to this power plants. Okay, so when it gets to the power plant, right, then basically it is transported, to basically they have it in such a way that, okay, first in, first out. So basically the last to come in goes further, the pile, in the coal area. Okay, so the one that came earlier on is the one that is going to be processed, right? Okay, so basically from the coal power area, it goes on conveyor belts, right? And I'll show you pictures of how those conveyor belts look like, okay? And basically, these conveyor belts are operated by motors, right? And depending on the amount of coal that is required to fill those beams that are in the power plant area to support the boiler, that is all calculated. So then from there, it goes through a pulverizing. The coal, remember the coal comes in the form of rocks, right? Miniature rocks, and a little bit, close to powder, right? So it has to go through total crushing, where the miniature rocks and quite close to powdery form is totally crushed into fine powder. And this is achieved by a PA fan. Basically, it goes through a pulverizer. It goes through a pulverizer. Then integrated to the pulverizer is a PA fan, right? Because once the pulverizer crushes, now the pulverizer is like a mill, okay, quite close to a mill, right? So what it does is, once the coal comes from the silo and goes under the mass rotating mill, right, it crushes it into fine powder, right? So to get the fine powder into the boiler, you need a fan. So that is what they call a PA fan, right? Primary air fan. That is the meaning of the PA fan. So what the fan does is basically, is integrated to a model that basically creates that air movement to blow the pulverized coal into the boiler. So as you can see over here, right, crushing and pulverizing of the coal, then you have the PA fan basically blow the pulverized coal into those burners, right? The boiler has various burners that are integrated to all sides of the boiler, right? All around. So you can have about 10 to 20, burners, right? So where this pulverized coal that is in the form of a very fine powder basically goes through those burners and gets ignited and basically forms a combustion chamber. So here, as you can see over here, you have a burning combustion chamber in the boiler, right? Okay, so right around the walls, right, of the boiler are basically tubes all around that basically goes around the peripheral of the boiler, and basically as the pulverized coal gets burned, it generates a lot of heat, and that heat is transferred into the water that is flowing through those tubes around the peripherals of the boiler. So what does it form? It's semi-steam, right? About, let's say, 30% water and 70% steam, right? So that is the composition of the water material that is formed around those tubes, that is all embodied on the boiler material. Okay, so now you have a steam that is generated, right? The heat from here, let me rephrase it again, okay? The heat from the boiler is transferred through the water that flows around the peripheral surface of the boiler, right? And that creates about 30% of water and 70% of steam, right? Okay, so the goal is to get this steam as dry as much as possible, right? That is part of our thermodynamics, right? Part of the cycle of thermodynamics is to get the steam as dry as possible. But now you have 30% saturation in and 70% dry steam. Even then, this 70% has to be dried further, right? So it goes through different stages, right? The superheater, right? So those are pendants of tubes that are higher up the boiler, right? That basically helps to reheat the steam that has this composition, right? So the goal is to get it as, let's say, 95% steam that is very dry and has 5% saturation water. So then it gets to the top of the boiler. That is called a super pendant, you know. So that one also introduces an additional heating. So basically the steam that is coming out of the boiler is about 98% dry and 2% saturated with water, right? Okay, so that comes out into the high pressure section of the turbine, the steam turbine, right? So now I have the steam that has been created out of the boiler, right? And the steam goes through a length of piping, right? About, I would say within the power plant, I would say quite close to like a quarter of a mile of piping. And you can just imagine this amount of flow, mass flow rate of steam. Matter of fact, one time, you know, during an animation process, they basically mimicked if there should be a bursting of a high pressure steam piping that carries that amount of steam, what damage it's going to cause. Right? That can sever you into pieces. So that should tell you the mass flow rate, right? That's a lot of mass flow rate of dry steam flowing into that piping that gets into the high pressure section of the turbine, right? Okay, so as you can see over here, right, the high pressure section has smaller blades, right? The blades are much smaller in shape, right? So once the steam impinges on those smaller blades, it starts turning the wind it starts turning the steam turbine, sorry, right? So then it gets the turbine rotating. Then once the turbine is coupled to the generator also starts turning at the same time. This is the coupling between the turbine and the generator. So at the same time that the turbine is turning, the generator is also turning to start generating gradual buildup of voltage across its terminal, right? Okay, so this high pressure steam, basically after going through the high pressure section of the turbine, basically comes back and goes through the condenser, right? So the condenser has a closed loop with cooling water that comes from a river, right? Okay, so this is the flow in and the flow out, right? In the closed loop. Okay, so once the steam, after going through the high pressure section of the turbine and comes down here and gets in touch with those piping in the condenser that carries cooling water, basically the steam collapses into water, right? So it forms a pool of water at the base of the condenser and ready to be pumped up to start the next cycle. So you have a condensate pump motor here that pumps the condensate. Then it goes through boiler feed pump motor. Right? So the boiler feed pump motor is the one that pumps the water through the walls of the peripheral of the boiler for it to be reheated again to complete the cycle. So the cycle is a closed cycle. So it continues like that. Then once after the high pressure section, right, then you have the steam also coming back, right? Sometimes the high pressure section goes back to be reheated, right? Then because after the steam goes through the high pressure section, it has lost some amount of temperature, right? So it needs to be reheated. So it goes back to the reheat path through these pendants, then comes back into the low intermediate pressure section or the low pressure section before it gets down here to collapse into water to complete the cycle, right? Okay, so this continues until the required terminal voltage is generated. Let's say 13.8 kV, 18 kV, 21 point something kV, before it gets into this step-up transformer that steps the voltage up to 115 kV, 230 kV, 345 kV, because before it goes into this electrical transmission system that goes all the way, various miles before it gets into a sub-transmission system that steps the voltage down, let's say from 230 kV to 69 kV or 115 kV or 345 kV to 115 kV. Okay, so from the sub-transmission level, that is when you want to step it down further to achieve a distribution level voltage. Okay, so remember, I made mention that the means of transportation of the coal is either through barge, which is basically leverages the rivers that are in close proximity to these power plants, right? Okay, or you can utilize trains, or 18-wheelers. So these are the various means of transportation of the coal to the power plants. And like I made mention that during the feasibility studies of these power plants before they are built, a lot of these studies are done to determine the means of transportation of the coal to these power plants. And if there's a need to build those rail lines, if there's the need to build extension to those rivers to allow those barges to be able to, and other additional infrastructures that has to build to allow those barges to dock and basically the coal to be offloaded from these barges. So next is a typical picture of a barge, right? That is a river that is in close proximity to the fossil power plant, the coal power plant, right? So as these barges basically, dock, right? There are infrastructures that have been put in place to help basically the offload of these coal onto conveyor belts. So next is a typical picture, very, picture that shows you how the coal piles in a typical coal power plant, right? So as you can see, as the coal come in, they are poured into piles, right? Okay, so, and a lot of emphasis is made on what comes in first has to be offloaded onto the conveyor belt to be sent to the power plant, right, for pulverization and to be fed into the boiler, right. So that is how they basically, help basically, so that coal that is brought in basically, doesn't stay there in the coal pile for that long, right? Okay. So and also there are times that sometimes to prevent fires, like the coal pile is basically you have a truck in the coal power area at the power plant that basically helps to move the coal around. The goal is basically to prevent fires, right? Basically, and sometimes they have to spray water, mist of water and all those things to mitigate fires and all those things. Okay, so once it gets to that coal pile, the next uh, path is to get the coal on the conveyor belts. This is how the conveyor belt looks like, right? And basically it has a lot of motors, right? That basically helps out this conveyor belt to move, So, but like I told you, there is optimization in place, right? Planning in place, right? That basically coal comes in, they are basically shoved into areas, piles that has naming, that has dates that this coal came in, and the time that this coal pile has to be relished onto this conveyor belt, onto the silos in the main plants. Okay, so this is basically a 3D picture of how the conveyor belts look like. Okay, so this is a long conveyor belt. So this part is the coal yard. So the coal yard, like I told you, has a whole lot of optimization in place, right? Coals that are brought by barge, by train, or by trucking, right? And they all have dates, where they come from, the type of coal, and the composition of the coal, right? And everything is planned on when that pile will be offloaded onto the conveyor belt into the main plant for pulverization, right? So this is just basically a length of belt that has the coal pile that is in the form of rocks, miniature powder, basically, ready for pulverization before it goes into the boiler. So as this coal pile traverses all that length of the conveyor belt, it goes to the very top of the power plant, right? So this is the very top of the power plant, and you have silos, right? That has been installed in various lengths along this radial path, right? Okay, so this coal basically goes into that silos and basically fills the silos. Then from the silos, it goes to those pulverizers that basically grinds the coal into fine powder, ready to be fed to the PFN. So the PFN is the one that blows the fine powder and pushes it into the boiler. So this is an example of how the silos look like, okay? So you have all that length of conveyor belts, right? All the way. I've shown you how the conveyor belts look like. Then it comes in, then it fills all these silos, right? Right. So from these silos, then it goes through the pulverizers. So I told you that the pulverizers is just a mill, just like a mill, like you mill corn, right? So its goal is to grind the coal into fine powder. And once it basically is able to achieve grinding the coal into that fine powder, then you have the PFN, the output of the mill. Is basically you have the PFN that blows air to basically integrate that fine powder into and feed it into the boiler. So this is a typical picture of inside the boiler. So that tells you, all the combustion process that takes inside the boiler, right? Okay, so you have the pulverized coal that goes through burners at various, you can have about 10 to 20 of them, depends on how large the size of the power plant is, how large the size of the boiler is. You can have about 20, sometimes you can even have 30, basically burners, right? So basically this pulverized coal goes through the burners, they're ignited and they burn, So the heat is what is transferred into the water that flows through the peripheral walls through tubes. And that heat is transferred into the water to create steam. And like steam rises, So that steam basically rises into the next layer. And from the next layer, it goes into different pendants to get reheated to form. The goal is to basically at the top of the boiler is to get the steam as dry as much as possible, like 98% very dry steam before it goes into the piping to go into the turbine, right? What's the process, that takes place? So as you can see over here, the pulverized coal comes into this, and these are all the burners, right? These are the burners, and basically, and as you can see, the burning, and you have basically, basically the water that gets heated, right? Gets heated and forms into steam and rises up here and basically collecting to here and gets reheated and basically forms, the goal is to get it 98% as dry as much as possible before it gets into the turbine, right? Okay, so as it goes through the turbine, it comes back here. This is basically a closed loop water, cooling water that comes from the river from this side, right? Okay, so the river flows from a closed loop cycle. So as the steam from the turbine drops down and it gets into contact with this cool water, basically collapses into water. So this is the bottom water that basically flows to the condensate pump model, and the condensate pump model, pumps it to the boiler feed pump. Then from the boiler feed pump, it comes back into the boiler, right, as a closed cycle. So similarly, same thing right here. Okay, so similarly, like I indicated to you, this is the pulverized coal comes into here, gets, basically, heated, burned. The coal fine powder gets burned, and basically you have a water boiler feed pump motor right here, right? Basically pumps the water. So as the water flows through here, it gets heated, right? So you have about let's say 20% water and 80% dry steam, right? So it rises up here, right? Then it gets reheated, right? So reheated, and it goes through another one superheater before it basically comes into here like 98% dry steam and 2% water. It comes down here, goes through the turbine. Once it hits the turbine, basically it rotates. Then it comes down here. Then the closed loop from the river. So this is the river, but basically the river sends a cool water that basically gets in touch with the steam that comes back and basically collapses the steam into forms the water. Then it comes back into the boiler feed pump. Then basically the closed cycle repeats on itself. Okay, so this should be the last presentation, right? Okay, so this is my YouTube channel, Work and Happiness Talking Today YouTube. Okay, so but for you to be able to subscribe to this YouTube channel, you need a Gmail account from Google, right? Okay, so after listening to my video, don't forget, if you like it, don't forget to select the like button and don't forget to share, right? For you to be able to subscribe to my YouTube channel, right, you need to have a Gmail account, Google account, okay? And if you go to my YouTube channel, it has tons of presentation materials that is very good for an engineer that's about to start your career. A developing engineer. Right after you start your career, you develop yourself. Right? in between two mid-career, and also a mid-career engineer, and in between mid-career and experienced engineer, and consultant engineers, right? And sometimes experienced engineers and consultant engineers, we all need refreshers. Right? So this also can be a refresher for them. With that, I'll say thank you so much for your listening, yes, and look out for much more interesting presentation that I'll present to you in the future. Thank you so much.